Hi guys, this is the continuation of the ASTEC interdisciplinary material. We're doing the mathematics section. We just got done with a statistics note here that if you're wanting to find the probability of a set of numbers and you're trying to find a certain number of even or odd numbers in a set. So they ask, for example, what is the chance of choosing two even numbers in a set, or three even numbers, or two odd numbers, or three odd numbers, for whatever. The way you do that is, well, if they ask you how to find two, you just multiply two fractions together, two probability fractions. The first fraction is going to represent the chance of finding the first number, whether it be even or odd. And the second number is the probability of finding the second number, etc. The third fraction would represent the chance of finding the third number, whatever. So, and the fraction, each fraction is going to be the number of even numbers or odd numbers over the total number in that set. And each subsequent fraction is going to have one less than the fraction before it, because you already took out, or you counted one even or odd number, so it's going to have one less. So if you have 13 numbers total in a set and there's 8 even numbers, you go 8 over 13 times, in the next fraction you reduce it by 1, so times 7 over 12. If you're finding a third even number, times 6 over 11. So you would multiply those three fractions, 8 over 13 times 7 over 12 times 6 over 11, and the result would be the fraction representing the probability of finding three even numbers in that set. That's how you would do it. And same thing for odd numbers. You would just count the number of odd numbers and over the total number of numbers, and you would use the same process. Got it? We got it. Say, hey, yeah!
Alright, yeah.
Woo! The next section is multiplication. Multiplication includes integers, factors, multiples, prime numbers, composite numbers. All of this stuff we've reviewed. Integers are positive and negative numbers plus 0. Factors are any two or any number of numbers that you multiply in order to get a product. Multiples are when you have one number and you multiply it by a sequence of numbers, like 1, 2, 3, 4, 5, and you get multiples of that one number, the first number. And then prime numbers are numbers that can only be divided by itself and 1, and they have to be greater than 1. The prime number has to be a natural number greater than 1. And then the composite number is the same as is the opposite of a prime number, in that it can be multiplied. It can be divided by a number besides itself and 1. So, but it's also natural. So it's greater than 1, but it has a third number that can divide into it besides just itself and 1, and this is called a composite number. So most numbers, well, all numbers are either prime or composite. All whole natural numbers greater than 1. Okay, so again, integers are not natural numbers occurring. They're all numbers, including natural numbers. So all the negative versions of natural numbers plus 0 are integers. So natural numbers being 1, 2, 3, 4, 5. Integers are negative versions, -5, -4, -3, -2, and -1, 0, 1, 2, 3, 4, 5. All the sides of the 0 on the x-axis are integers. Example, 5, 10 are integers, -5, -10. Factors are numbers that can be multiplied together to equal a third value. Or you can have any number of factors depending on how many numbers you're multiplying. The factors of 12 are all the numbers that can multiply into it. So 1, 2, 3, 4, and 6 are all factors of 12. Factors of 14 are 1, 2, 7, and 14. So they evenly divide into that number are all the factors. Of 18, the factors are 1, 2, 3, and 9. And obviously 1 is the factor of every single number, because you can divide all numbers by 1 evenly, or all natural numbers. And then multiples, when you take a given number and multiply, the result is a multiple of the given number. So basically you're counting by a certain number. So the multiples of 4 are 4, 8, 12, 16, 20. If you count by 4, if you count by 5, you get the multiples of 5, 5, 10, 15, 20, 25. So the difference between factors and multiples, factors are smaller, they go into that number. Multiples are bigger. They're like an extension of that number. So not to confuse the two. 24, let's see. Oh, wait. And sometimes if you look at the multiplication table in a horizontal way, you can look at multiples. So like multiples of 3 would be 3, 6, 9, 12. So 3 times 1, 3 times 2, 3 times 3, 3 times 12. So again, prime numbers must be a natural number greater than 1, positive, and it must have no divisors that will divide into it evenly other than 1 in itself. Example 3, 11, 7, 5, 2, 13, 19. Those are all prime. Composite numbers has divisors other than itself and 1. 4, for example, it can be divided by 1, 2, and 4. Examples of composite numbers are 6, 10, 14, 15, 16, 200. Okay. Neither prime or composite are the numbers 0, -1, and 1. Wait. -1. I thought, okay, because they have to be greater than 1. So if a number is, so basically they start at 2, because everything over 1 is prime, greater than 1. So the numbers 0, -1, and 1 are not prime or composite. They're neither. 1 is a natural number, however, it's not prime, nor is it composite. Prime and composite numbers must be greater or larger than 1. So 1 is neither a prime or a composite number. And, well, 0, -1, and I guess all the negative numbers. I don't know if... So confirmation from the Wikipedia robot, thanks to Ruben, Googling it, confirms that prime numbers are, in fact, greater than 1. So only positive greater than 1. And numbers that can only be divided by itself and the number 1. And so the composite numbers can be divided by another number, at least one other number besides itself and 1.